In this lesson, we will solve a seemingly complicated equation by spotting a hidden pattern. The goal is not just to get the answer, but to build intuition for recognizing and using substitution. Here is the problem. Open parenthesis x squared plus x close parenthesis squared minus 8 times open parenthesis x squared plus x close parenthesis plus 12 equals 0. The key observation is that the same block x squared plus x repeats. Rather than expanding to a messy fourth-degree polynomial, we rename that repeating chunk. Let's highlight both appearances of the same block. Now, define u equals x squared plus x. Then the equation becomes u squared minus 8, u plus 12 equals 0. Now we are in familiar territory. This is a standard quadratic in U. We need two numbers that multiply to 12 and add to negative 8. Let's examine factor pairs of 12 and check their sums. The pair negative 2 and negative 6 works because they multiply to 12 and add to negative 8. So the quadratic factors as open parenthesis, u minus 2 close parenthesis times open parenthesis, u minus 6 close parenthesis equals 0. Therefore, u equals 2 or u equals 6. Remember, u equals x squared plus x. So we create two cases, x squared plus x equals 2 and x squared plus x equals 6. For the first case, subtract 2 to get x squared plus x minus 2 equals 0, which factors into open parenthesis x plus 2 close parenthesis times open parenthesis x minus 1 close parenthesis equals 0. So x equals negative 2 or x equals 1. For the second case, subtract 6 to get x squared plus x minus 6 equals 0, which factors into open parenthesis x plus 3 close parenthesis times open parenthesis x minus 2 close parenthesis equals 0. So x equals negative 3 or x equals 2. Collecting all solutions, we get x equals negative 3, negative 2, 1, and 2. These come from the two simpler quadratics after our substitution. Intuition tip. When you see a pattern like open parenthesis, something close parenthesis squared plus a multiple of the same something, treat that repeating something as a single letter. This turns a hard fourth-degree problem into an easy quadratic. So the strategy is spot the repeating block, substitute to a simpler variable, solve the quadratic, and substitute back. Structure first, algebra second.